chemical reactions and chemical reaction rate. By the word rate, I mean how fast or slow the reaction will go. The reaction will take place. And we will learn how to calculate the reaction rate. Alhamdulillah, it's a short one. It's a short one, inshallah. First of all, what is the reaction rate? Some definitions. The rate of chemical reaction expressed as the rate at which the reactant is consumed or the rate of the product is formed. Let's see, this is my reactant. This red thing is my reactant. Remember what are the reactants? The substance that you will start up my reaction. At time zero, I have 100% of reactants, right? As the time goes, my reactants are consumed or disappear. See, the red things are disappearing. While the blue stuff, what are those blue stuff? Those are my products. So the rate at which, how fast or slow this reaction goes, or you can say when the reactant is consumed, or also you can say the product will be formed. The reaction rates are generally calculated or expressed in moles per liter per second. Mole per liter per second. I will show you how this unit comes. In order for anything in the world to react, they must collide, they must hit each other, and not just a normal collision. They should be effective collision, okay? The rate of chemical reaction is unrelated to spontaneity of the reaction. I mean, the reaction will take place or it will not take place. This is another story. Okay, so in order for anything in the world to make a reaction, I just said, if you want to make those particles to make a reaction, they have to collide. They have to hit each other, right? In order to collide, they must have energy to collide. They need to move all the time, right? So you have to give them a spark of energy. I always say this word. You know, when you want to burn a piece of paper, you have oxygen in the air, you have the paper in your hand. Why combustion process didn't take place? Why the burning process, it's not taking place? Why? Because you need a spark of light. You need a small amount of energy to start my reaction. We call this energy activation energy. This minimum amount of energy that you need to make the particles collide. They must make this collision to react. And this energy, we called it activation energy. Let's discuss again. Let's say if I have hydrogen molecule, 2 molecules of hydrogen and 1 mole of oxygen. Okay, what if I have 2 moles of hydrogen and 1 mole of oxygen? In order for this reaction to take place, these just 3 moles of stuff, no reaction. So in order for this reaction to take place, what they need, please write in the chat box. Show me that you are here. They need what? They need to collide. Excellent. In order to collide, they must have the minimum amount of energy. We called it activation energy. Good. I give them the activation energy. Now I had my reaction. Once I had my reaction, there is a complex will be made. This complex called activated complex. It's not the permanent product. It's not the product. It's something temporary. It's happening, unstable arrangement of atoms. And then right after this, the product will be formed. Let's say my products will be 2 moles of H2O. Okay, we talked about activation energy. Also, we mentioned the activated complex. Okay, now we have 2 types of reactions, whether it's endothermic reaction or exothermic reaction. Take a look to those 2 graphs before we discuss. The endothermic, whatever the graph is, take a look. I start up with reactants, and then I give them the amount of energy they need, which we call it activation energy, so they can start my reaction, and then go up. The energy is perfect. At this point exactly, the reactants start to colloid each other and they will make my activated complex. Once the activated complex is made, now no barriers, and they will go way down to make the product. Okay? This is basic in all of the reactions in the world. Activated complex and then go way down to make the product. Okay? Now, what are exothermic? What is exothermic reaction? What is endothermic reaction? Here we go. Endothermic reaction, it's a type of reaction that releases energy from the system. Releases energy from the system. Let's say I have ice and I need to turn it to, oh, sorry. Oh, let's start with this. Let's start with this ice because it's easier. And I need to make it liquid. In this case, this is called a system. My system need to gain energy or it need to lose energy. Let's talk first about endothermic. Now, this is very basic. I have ice, I need to melt it. You need to gain energy or to lose energy. Yes, thank you, Abdullah. To gain energy, very good. In order to gain energy, we call now the system here, it gained energy, we will give it positive sign. Now we call this process endothermic or endothermic reaction. It's a reaction that took place that they need to absorb energy. They need to absorb energy from the surrounding. I don't mean the activation energy. No, not at all. The activation energy, it happens in both ways. But here I'm talking about the reaction itself. At the end, they will gain energy or they will lose energy. In case of ice turning into liquid, here the system needs to gain energy. So now my reaction will be endothermic reaction. And I will give it a positive sign. Positive means the system gain. Okay, gain positive, gain energy. What about endothermics then? What about endothermic? Let's say you have a liquid, whatever the liquid, water liquid. And this liquid, you want to freeze it. You want to turn it into ice. In this case, you need to lose energy or to gain energy. In this case, the system, my system, need to gain or to lose energy. Please answer me in the chat box. My system want to lose energy, to decrease their energy, so the particles come closer to each other and make ice. So this reaction or this process will be called exothermic reaction. Exothermic reaction, okay? It's a reaction that releases energy from the system, so you can see from the system to outside, to the surrounding, okay? In this case, I will give my system a negative sign. Am I clear? Now let's discuss the graph thing. The graph, because it's very important. Let's discuss the graph. I need to clear this. This one. Okay, now let's see. What if you have an exothermic reaction? Let's discuss the exothermic reaction. Now you start up with reactants. Of course, you will always start up with a reaction, with the reactants. Okay, sorry, just a second. Here we go. The reactants is over here. As you can see, they have good amount of energy, right? But still they need activation energy, even though they need activation energy. This example, like burning, like combustion, like burning a paper, although they have enough amount of energy, they have good amount of energy, but yet they need activation energy to start up the reaction, make the activation complex, and then go, we make the product. Can you check the product? See way down? See the energy of the product, how low the energy is the product. Here I'm measuring the energy versus the progress of my reaction. If the reactant has more energy than the product, or let me rephrase it, if the product has less energy than my reactant, then this reaction lost energy. This system lost energy. So this is exothermic reaction. But in the other case, let's see the second graph. You have, of course, the reactants, and you need big amount of activation energy until you reach the peak here, up here, and make the complex, and go make the product. Did you notice the energy of the product? The product energy is way more than the reactant. Somehow, this system gains energy, and this is called endothermic reaction. Okay, I hope the pictures were clear enough, because those two graphs are very important. Just a point, I found a small question about if you have 1 mole of ice, 1 mole, particularly 1 mole of ice, you want to turn it into 1 mole of water. This process, as you all know, is called melting. We can also call it fusion. Okay? In this case, I will call it molar heat of fusion. The amount of energy, that will be gained, will be always positive value, and it will be called molar heat of fusion. طيب, if you have water, 1 mole of water, and you need to freeze it. So in this case, what do you need? You need to lose energy or to gain energy. Please write in the chat box. Gain or lose energy? Lose energy. Very good. In this case, the system will lose energy. Specifically, this number, it's not you shouldn't memorize it. And we will call this process solidification. And if you have 1 mole of water to be solidified or freeze, we will call the molar heat of solidification. Okay? Exactly when I have liquid, no, you shouldn't memorize the number, not at all. Exactly, if I have liquid, I need to evaporate into gas. So you will calculate what if you have 1 mole of liquid, you want to make it 1 mole of gas, 1 mole. So you will calculate the molar heat of vaporization. If you want to do the opposite, it will be molar heat of condensation. By the way, the molar heat of vaporization, molar heat of condensation is exactly the same. That's why I added the numbers, not to memorize it. Don't memorize, but I want you to see that they are equal to each other. Okay? Now, I need to speed up my chemical reaction. I have banana in my fridge for 2 weeks. I need to eat my banana. I need this reaction to take place. What is your advice? I need this reaction to be faster, to speed up my chemical reaction. What is your advice? What is the first thing that comes to your mind? Huh? To the fridge. You need to increase the temperature. Okay, so in order to speed up or to slow down some chemical reactions, you need to discuss or you need to know many factors. Number 1, raising the temperature will speed up the reaction rate, while decreasing the temperature will slow down. Okay, increase the rate, increase the temperature. Decrease the rate, decrease the temperature. Clear? What about catalysts? If you want to speed up your reaction, you should add catalysts. Catalysts will increase the rates of chemical reaction. How they will do so? By lowering the activation energy. See, you need this amount of energy, this big amount of energy to start up your reaction, to make your complex and go, make the product, right? But luckily, subhanallah, we have catalysts. The catalyst will lower the amount that you need, only this amount of activation energy you need to start up your energy. You have this. I have to integrate this with biology. Already you took the enzymes. You all know that enzymes are the natural catalyst in your body. Alhamdulillah that you have enzymes, because You cannot increase your your normal body temperature more than 37. Can you increase your temperature to 50 degrees to make any reaction? You will cook your internal organs though. Now, there are two factors I will mention, but I didn't find questions about them. We need to discuss 4 factors. The most important factors, 2 factors, are temperature and catalyst. The other 2, if you, if you decrease the particle size, it will speed up your reaction. Is it better to have a cube of sugar in your tea, or to cut it into small powder sugar? What do you think? Of course, decrease the particle or increase surface area will speed up my reaction, or to make my reaction faster. And the last factor, the particle size is the last factor. Factor number 3 is discussing the concentration. Increase the concentration here. You will speed up your reaction because more collisions, so the reaction will go faster. Now, can we calculate the reaction rate? Yes, I mentioned in the beginning. I mentioned the concentration. No, I just mentioned the concentration. If you want to speed up, where are you? If you want to speed up my reaction, you have to increase the concentration of what? Of the reactants, of course. I need more reactants to speed up my reaction. If you want to burn faster my paper, increase more oxygen, add more papers. So increase the reactant. So the rate will be directly proportional with the concentration of reactants. Is it clear? This is basically the formula. And we call this the rate law. Okay? We found out that the rate is directly proportional to the concentration of reactants. And by A here, I mean reactants. Let's say if A turns into B, so A is my reactant. But I cannot use this sign. This is just the relationship. I need numbers. So adjust your formula. Rate equals K multiplied by A. And K is a constant that I cannot explain it to you because it's a long story, but I can only tell you that this constant is determined experimentally. I have to make the reaction to calculate the constant, or this constant. Also, what is this number? What does this initial means? Suppose I have 2 moles of A, or let's say 2 moles of A, okay? It will make 2 moles of B. So the rate should be the rate, if you want to calculate the rate, equals K multiplied by A to the power of 2. The number of moles, or this coefficient that is written here, it should be the exponent. Okay? How I can calculate it? Also experimentally. So you have to do the experiment to calculate this value. But this number or this coefficient, it's already written, no problem. For a complex reaction, the rate determining step limits the instantaneous rates of the overall reaction. We have another type of reaction. We called it multi-step reaction or complex reaction. It's basically a long reaction where you have A will turn into E, then E will turn into B. So at the end, you will have, the A will at the end will turn into B, but after long steps. We call this is a complex reaction. Okay? There is always one step of them that is determining, or the rate determining step that determines how fast or slow my complex reaction will be. Now let's go to the questions. Question time. Now I need your participation, please. Is the rate by which reactants are consumed or products are produced? It is the rate by which reactants are consumed or products are produced. What is this Definition for 1C. Yes, thank you so much, Dalal and Lean. The chemical reaction rate. Yes, reaction rate. Question 2. Energy needed to start up the reaction. What do we call it? Activation energy.